So hello guys, in today's video we'll be doing the question number 543, the diameter of binary tree. So the question is basically we have to find the maximum diameter of the binary tree. So if I break it down in simple word, what we have to do is we have to find a path which has the maximum number of edges. Okay. Now in this, if we try to find the diameter, it's like 1, then 1 again, it's 2, from here we go here, and from here it's 1, and from here we go here. So total is 4. Okay. As usual, we'll be applying DFS for this approach, and we'll be recursively going down to every node, and when we'll visit every node, we'll update the height. From here, we'll make 2 pointers left and right, and we'll take maximum of left or right for the height, and we'll update it in the diameter. We'll update it using 1 plus whatever is the max of L and R. Okay. In DFS, we'll visit the left node first, then we'll visit the right node first, and we'll make it in a variable. Now we'll also update the diameter. Equals to max of cell dot diameter comma left plus right. And now we will return the maximum height, return 1 plus max of left comma right, and we will call the DFS So yeah, now I'll explain my code, like what is happening in this. First, let me make, yeah, we'll take example from this tree. What is happening is basically we are starting from this root. We are starting from this root, and then we are going to left and we are going to right. And when we are going from this node, then we'll go to the another node. This is basically the DFS approach. We are going as deep as we can go. That's what she said, by the way. But okay, jokes aside. Now we'll go more deeper, and we'll go until there is no node. here. Now in this part we return, but what we return here is we return the we return this thing, the maximum of left and right. So when I come to this node, like this is nothing, this is 0 and this is also 0. Now we'll go on to this node, and when we'll go to this node, as you can see, we return here is, sorry for the handwriting here. Here we return the maximum. Here we return the maximum 1 plus max of wait a second. Here we return the max of L comma R, which is basically left and right. But as you can see here, left is equals to 0, right is equals to 0. So what it returns here, the height of 2 to 4th node is returned 1. And then we return, and then we pop this and it goes to 2. Now 2 calls the right stack, but right there is no right child of 2, so we go upwards again. And now when we go from 2 to 1, we again, now we see the left part is already 1 and right is 0, 1 comma 0, and we take 1 plus max of L comma R, which is what, which is 1 comma 0, and this is guys maximum. We have to take the maximum. So here what it returns 2. Now the diameter is 2. Now here we have also made a variable which is self dot diameter. Okay, and now from node 1 to node 3 we go right, and at every node what we are doing, we are going to the end and we are trying to find the maximum depth of each subtree, and we are comparing between the left and right, and in diameter will add the maximum left and maximum right. Here the maximum left was 2 and here the maximum right is 1. So what we do is 2 plus 1, and in the code also what I have done is, first we made a self dot diameter, a variable to update the diameter. And why I use self I used because in the DFS function which I made, to use the diameter variable I have to use it recursively, like in every call I have to update this diameter and I have to use it again. So I use self. If I'll not put self, what will happen is it will give a runtime error. See, yeah, because in the function it doesn't know what is the diameter because we haven't defined the diameter, and here I have defined it globally, and when I have defined globally, then there is no problem. Yeah, okay. Now if we go to a node where is like there's no node, so we return 0. Then we do DFS on left node. First we go to the every left node, then we go to the right node, and at every, like if we go to the last node, then we'll return the diameter with maximum of self dot diameter, which is in the first step it's 0, and left plus right is basically the height of every node we are calculating from below. And here in the first step, when we first, second, third, in the third step, when we go to the fourth node, basically this node, in this node first time we get diameter equals to 1 because this thing executes, and left and right is 0. Still here left and right is 0. And when we go up, then we have left equals to 1. and right equals to 0. So recursively this happened, and I hope this code is very clear to you. If you have doubts, comment in the comment box and I'll try to reply. Thank you guys.